Good morning, good afternoon, folks. We're just nearly at the top of the hour, so we'll give it another 60 seconds before we start today's webinar. Hi, good afternoon. Hello, and welcome to our latest webinar from 42Crunch. There's quite a lot of folks signed up today, so we're really looking forward to having a very interactive session on the top things you need to know about API security. We've got a treat in store today for you, as we have a returning presenter, Philippe de Ryck of Pragmatic Web Security. Philippe's reputation precedes him as a friend to developers looking to build secure applications. And as he says himself, his mission in work is to teach practitioners around the world the ins and outs of building secure software. And of course, he's joined today by 42Crunch's own Isabelle Mauny, field CTO and co-founder here at 42Crunch. Just before we start, some quick housekeeping rules. All attendees will be in mute mode. You can submit questions via the Q&A, and we will look to answer those at the end. So as we go through the session, please submit questions, and we'll capture those for the presenters. A recording will be shared within the next day or so, so please look out for that. We'll be sending you all emails. And just to ensure that you're being attentive throughout, we'll push out a few polling questions, and it's your chance to participate directly in the webinar. So keep an eye out for those as we go. So without any further ado, I'd like to hand you over to our first presenter, Philippe.
All right, thank you for that introduction, you. Just for the record, we have interesting content as well to make sure you're attentive. The polling questions are just like the sneak behind the door to make sure things are happening. So just to make that very clear, we have Isabelle here as well. Isabelle is going to do some awesome demos. So yeah, that's essentially what we're going to do for the next hour. And we're going to talk about API security. When you talk about API security, a good place to start is, of course, the OWASP API security top 10. And what we're trying to do here is, in case you're not familiar with OWASP, OWASP is this nonprofit which has been around for decades, actually, trying to aim to improve the state of web security. And OWASP has had this top 10 document for a while, and the top 10 is not this exhaustive list of security issues, but it's more of an awareness document saying like, hey, developers and whoever building web applications, these things are kind of really important, and you're supposed to pay attention to these issues when building applications, and then of course dig deeper and deeper and further enhance the security of your applications. And that top 10 document has been working really well, has been updated a couple of times over the years and so on, until we came into the modern world. And in the modern world, we have API-based applications. And then the question became like, yeah, but the top 10 is great, but some of these issues are not really relevant for APIs, like cross-site scripting and APIs doesn't really work well together. So what's the point of doing that? And that's why about 5-ish years ago, I think, a project within OWASP created the API security top 10. And these top 10 issues are what plagues APIs today. They're very dangerous issues, very common issues, and they have a significant impact on your API. And today we're going to use this as kind of a guideline to walk through a whole bunch of API security issues, and we have some links to other content at the end as well. So that's essentially the agenda for today. And we have 3 concrete topics to talk about. And the first concrete topic is going to be authorization. And if you want to highlight this in the top 10, we have one topic, authorization. We're going to tackle 3 out of the 10 issues. So that's 30%. Very simple math here. 30% of issues can be covered just by talking about authorization. So yeah, authorization is important and authorization is crucial. That's essentially the takeaway here. So yeah, we're not going to wrap it up here, but that would be the very short version of the webinar. Authorization is important. Real world systems. Authorization is definitely an issue. I see that day in, day out when I work with developers, because when I talk about authorization and I give people like pointers of what to look for, they'll quickly identify the same issues in their APIs. And you've seen these stories in the news. If you follow apisecurity.io, great newsletter, you'll definitely find a whole bunch of authorization issues pop up there. And if you follow news stories, you'll get other of these stories as well. And we're going to use one as an example here, and that's a smart scale. Yeah, I'm not sure about the use case here. Smart scale with an app, there might be some use here, but the whole issue here is not the usefulness of the product, but mainly what happens in this smart scale product. It's a scale that can upload data through an app with an API and so on and so on. And they have family management features as well. Like you can add family members because you share the same scale, and people can take their own weight measurements and so on and so on. And it turns out that this smart scale API had a whole bunch of vulnerabilities. So unpatched bug chain says the title here, and there's actually a whole bunch of issues in this smart scale API that cause a lot of problems. Now we're going to start with authorization. And what somebody discovered is that the API serving the app, the Android app and the iOS app, did not really implement any authorization checks. Like nothing whatsoever. So if you want to add or delete family members to accounts, I mean, it's just a matter of calling the API and doing whatever you want to do, and the API will gladly oblige and do whatever you ask it to do. And in case you're wondering, that's kind of the baseline. That's not where you're supposed to end. That's where you start building authorization logic in your APIs, and you're kind of supposed to do something else. That's essentially the starting point for the story here. And that brings me to Isabelle here, because we need to ask ourselves, like, why does this work like that? Why is authorization so hard to get right? Do you have something to add here, Isabelle? Do you want to pitch in on why you consider authorization difficult and hard to get right? What do you see happening there?
Well, what we see, thanks for the question first. Well, we see a lot that happening at our customers really is it's usually something, it's like doing monitoring, after the fact. If you've not planned it as part of developing the API, adding authorization checks at different levels that you're going to talk about now, after the fact, once the code is released and everything, and we realize we have problems, it's actually pretty difficult to do. So in general, it takes a lot of time to address those issues and a lot of effort. And it's also hard to find those problems before somebody else finds them for you. So that's what we're going to talk about as well.
Yeah, absolutely. I would add, what I see is people often approach authorization as kind of this development problem too, like which checks go where, which often results in a mess, especially once you have somewhat complicated logic. It's going to be messy and checks all over the place. And whenever you do a security assessment, and I work with developers, I ask them, like, where do you check this or how do you check that? And nobody knows. It's like maybe one person in the room is like, yeah, I think we check it there, but then they have to go look and they're like, oh no, apparently we don't. And what I always like to say there is, my advice is to approach authorization from an audit perspective, like make it auditable. Because if you can't audit your policy, if you don't know what it does, then you don't know whether it's secure. And flipping that perspective definitely helps in keeping things centralized, keeping things simple, as straightforward as possible, and so on. So yeah, that closely aligns with what you said, with the different layers and different levels and all the stuff going on. So awesome. Let's take a look at authorization. Why is it so hard to get right? It sounds very simple, and at the most basic level, authorization is not a hard problem. At the moment you dive into the details, it quickly becomes very, very messy. So I'm going to use the smart scale as the running example here. We have, this is Java code, so everybody in the world can read Java. That's one of the benefits of Java. You don't need to know anything else. Just read the code and you understand the code. At least that's how it's supposed to work. We have the API operation, the very fictional. I just made the stuff up based on the story from the smart scale, but we can add a family member. We have a family ID, we have a family member, and so on and so on. Probably not the most production ready code, but it does work on PowerPoint. So we're kind of good there. And we implement a permission check, add family member. That's already more than the smart scale was doing. So we're moving up here in the world. And we basically ensure that whenever a user is accessing the API, that they actually have the permission to add a family member. See, that wasn't so hard. So authorization sounds simple. Sometimes it is very simple, and we can definitely move forward. All right, good. That's step one. Don't worry, folks. We're going to dive deeper in a second. No worries. Things will get a little bit more complicated soon. Before we do that, you made a promise of doing some polls, so that's exactly what we're going to do next. We're going to play authorization pattern bingo. with this beautiful image from ChatGPT. So I don't know why it looks very Russian, but that's a different story for a different time. Anyway, the question that we're going to launch here, the poll is, we basically have the question being asked, which of the patterns we did solve? You should only answer the first question, not the second one. That's for later. Answer the first question, which of the OWASP API top 10 issues did we solve by adding this permission check you saw on the slide earlier? All right. I don't know. I hope you can see this. I'm not sure I can see it, so that's probably good. The answers are somewhat distributed, which is always interesting because it means it's a good question, or nobody cares and just clicks randomly, but I'm going to assume it's a good question. The correct answer, well, it already highlights a problem. You have all of these different authorization issues, and what we solved here was broken functional level authorization. And what's basically going on is functional level means a check whether the user or whoever is calling the API is allowed to access a certain operation, certain function, in this case, add member. And we solved the problem by adding a permission.
Sorry to jump in there, Philippe. Sorry, I didn't realize you couldn't see the results. Just so you know, 42% guessed correctly that broken function level authorization. So there you go.
Okay.
30% guessed BOLA, 24% guessed broken authentication, and the balance was BOPLA.
Yeah, awesome. Thank you for adding that context. So 42% got this right, and everybody else is somewhat over the place. So what's basically happened is functional level authorization essentially means that whenever you have operations, you check if the user is allowed to access that operation. That is functional level authorization. Often goes wrong. If that check is missing, you suffer from OWASP API security top 10 issue number 5, if I'm not mistaken, broken function level authorization. That's good, right? Now we have fixed functional level authorization. That brings us to the next authorization problem, and that's object level authorization. And object level authorization works as follows. I, as a family member, I'm the parent in my household here. So let's say I have a smart scale, which I very much don't, but let's say I have one. And let's say that I want to add my kids to the smart scale application. Whenever I make that API call through the app, the API will now check, are you allowed to add family members? Like, oh yeah, you are. Bam. And off we go. And that's good. That's essentially how you make a request. It's a post request to a member, endpoint, whatever. You can kind of guess how this works, right? You're in an API security webinar. You've seen APIs before. This is a request, and functional level authorization here is not enough. Because yes, I can add members to my own family, but if I'm somewhat savvy, I can open up this request in a tool like Burp. I can modify the 1 to a 7. I can send the request, and all of a sudden, I'm adding members to Isabelle's family because she also has a smart scale and so on and so on. And now I'm adding children to Isabelle's family account, and through that account, I can maybe access other data in that family's account and all of that stuff. And that's broken object level authorization. Because it's not enough to check, can you add family members? You also have to check, can you add family members to this specific family? And remember when I said that authorization logic can get complicated? Well, we're not going to dig deeper into the example, but I can explain what makes this complicated. Now, whenever you want to add a family member, the check becomes, are you allowed to add family members? Like, yes, you are. Okay, which family are you adding stuff to? Oh, family 1. Now you have to check that the current user making this request actually belongs to family 1 or has permissions within family 1 to add a user. And those checks get complicated very quickly. They often involve fetching additional data from a data store, making sure that the properties match up, and so on and so on. And that's essentially where you're evolving towards building an authorization policy, because spreading these checks out throughout your code is not a good practice. It's not something that will end well. And that, by adding that check, whether the user belongs to the current family and adding members to that family, that is solving object level authorization, or BOLA is the issue in the OWASP API security top 10. Number 1, very important issue. Awesome. We covered BFLA, broken function level authorization. We covered BOLA, broken object level authorization. And now we have the third one, number 3 in our trifecta of authorization issues, BOPLA. And BOPLA is a new issue. It popped up in the latest version of the OWASP API Security Top 10 because it's a combination of 2 existing or pre-existing issues. You have the read version of BOPLA. That's basically when the API is exposing too much data to the client. Like the response contains a whole bunch of data that the front end doesn't use, but it's there, so an attacker could inspect it. Then you have the write version of BOPLA, which used to be mass assignment. And mass assignment is when you provide additional data in a request, and the API consumes that data as well, allowing you to update fields in the database that you shouldn't be updating, but because of that additional data, it just happens automatically. And that is broken object property level authorization. Because just checking, can you add a family member to this family is one step. You also have to go further and making sure that whatever information you're accepting doesn't allow you to override fields you don't have access to, and so on and so on. And BOPLA is definitely the most complicated issue of the 3. And that's essentially why we have cool kids looking for demo time. That's where Isabelle is going to jump in, and she's going to give us some context on BOPLA. So let me just stop my share here and give control to Isabelle.
Thank you. So we're going to do this a few times. Stop sharing, start sharing, but that allows us to jump into the theory to the practice. So what are we going to talk about now? How do we detect those BOPLA issues, right? What is this all about? In the end, it's about controlling the data that comes in and goes out of our API. That's really what this is about. So what I'm going to do now is demonstrate this in our tools. All I've done, what you're seeing right now on the screen, is Visual Studio Code, on which I have installed our plugin. If you search for OpenAPI or 42Crunch inside the marketplace, you'll find it. You have the same thing in IntelliJ, the same thing in Eclipse, and you will be able to do exactly what I've done now because we have a freemium version that doesn't require you to just a little token. You give us an email and you'll be able to do the same thing I'm doing right now, okay? So once we have our extension, I'll just go to our Explorer, and we are going to open an OpenAPI file, okay? So for those of you who know 42Crunch, you know we're all about defining what an API does, describing as good as possible what is the functionality of that API. And one of the key aspects of that is defining how are you constraining enough the information that comes in and comes out. That is really what BOPLA is all about, right? So here I have this simple description of an API. And the first thing I'm going to do is running what we call an audit on this. Audit is really about taking our OpenAPI specification and doing an analysis on it on 2 aspects, right? One is a security aspect, and the one is a data validation aspect, which is really what we are interested in the context of BOPLA issues, right? And what is this data saying? Well, something, for example, very important. It says, here you have a problem that says you have a schema that allows additional properties. Let's go and see this. Where is that? So let's expand that a bit so you can read. And here it says, okay, we have a schema. It's called user update data. Okay. You know, it's not as easy maybe to read. That's almost as easy to read as Java, I guess. You can read it. Says there's an object called update user data. So usually it's going to be used to update a user, right? I'm supposed to pass an email and name if I want to update a user, and I have some properties in here. But see, you have this thing here that says additional properties true. Now, something which is very important for all of you, is inside the OpenAPI specification and in general in the JSON specification, by default, additional properties is true. What does that mean? That means that, okay, I have defined those properties. I have 3, email, name, account, balance. But because this is true, I could actually pass additional properties which are not defined. So I'm not putting here any limits on, maybe I could call this API now with 100 more properties in it. And if I were to validate that payload against that schema and would say, yeah, it complies, all good, I'm happy, because you told me, right, that additional properties is true. So I'm allowed to do that. Okay, so from a security standpoint, this is actually pretty bad because it opens the door to this mass assignment problem that we were just talking about. That means that anyone can come here and start pushing any kind of data to me, and I'm not even validating that that data is the right format to look. I don't even know anything about that data. So by default, when we do this analysis, we're going to tell you, no, you really don't want to do that. What you really want to do here is actually set that to false, right? Because when we are going to create an update a user, what else would you accept in here, to update your user that is not already defined, right? Okay, we'll save that. We'll do our audit again, and now this problem should be gone, right? Which is great. So now what we have done here is we have said, see, no more problem of that sort. It's gone from here, the definition. Great. Now this is the theory. The theory is I've said, when I'm exposing the contract of my API and I'm telling the others what my API does, I'm telling them additional properties is false. Oh, great. Now this tool, what it does is only looking at the theory again. It's looking at what you say. But right now, we haven't tested at all the implementation of that API to see that, in fact, if I'm trying to inject some data, what happens, right? What do we do in the API? Are we actually doing those validations or not? So that's what we're going to do now. We're just going to go and test interactively that API. And this is the second part. Let me just close that report. Now, this is the second part of the tools that we provide in the IDE for the developer, which is this interactive testing. So let me just go and try this first and say, okay, if I'm trying this, what is this API doing here? Is just taking a user and updating it, as we said. Okay, so if I'm trying it, I'm just executing that code in here. I'll do a login to log in with a user. I'll obtain a token, right? And then I'll try to update that user with some information, and it works. Okay, great. Now that gives my baseline. Like, I know this API is actually working if I'm sending it some good data. So next, I'm just going to do a scan. And what this is going to do is going to say, okay, you gave me a baseline. If the data is good, you give me some good answers. Now, what I'm going to do is just hammer this API with all kind of data except what it's actually expecting. And one of the tests, as we will see, is to try to inject some additional information. Now, you told me you could do, I should not be able to do it. Is it true or not? Let's have a look at those critical errors. Yeah, bad luck. The API accepts additional properties, right? So what we've done here, well, we've injected our account balance, as we said before, but also we've injected something else that is not defined. And what do we get? A beautiful 200, right? So the theory is I should not be able to do it. In practice, I'm actually doing it, right? So those are tools we're giving to the developers so they can, as they go and develop their APIs, back to the point when Philippe was asking this question, like, why is it so hard? It's also hard because it's, again, difficult to do this testing as we go and develop in a scalable way. Here we have something that will do it for me automatically from the definition of the API, okay? Now, this is one aspect. This is BOPLA, right? This is about the injection of data. Now we can also look at the same contract and see the data that comes back and see if actually it is also what we have specified in the contract. For that, I'm going to switch tools, right? And we're going to look at a full report, something a bit more, of the entire API, which is like a wider scope. And we will see here multiple critical issues. Let me just go and zoom in that a bit so you can all see properly. All right. So we can see we have a number of critical issues here. I'll just close that so it comes for the top. So we're going to find our API 6 here. That's the other side of it, right? That's the mass assignment, side of it. So we have multiple of those, multiple problems of we have injected some data and that got accepted. But as you can see, we also have some authorization tests in here. And this is the BOLA and BFLA part of the story, where we can actually go and test also interactively, hey, how do we test BOLA? How do I know I have a BOLA problem? The reason I can have a BOLA problem is I'm trying here as user Two, to try to delete a picture that belongs to user one, right? It comes back to the example that Philippe was going before, like I was trying to add a member to a family that I don't belong to. So I'm trying to access a resource I should not be allowed to access, right? So we can also automate those BOLA tests. And the same is true of BFLA tests. How do we test that we have a problem of the access at the operation level? Well, same thing. I'm trying to access this operation as user A, which is fine because in this case, this is an admin operation and I'm allowed to access it because I am an admin. But if I'm switching that user to a non-admin user, that should be rejected and it's not, right? So thanks to this tool, what we'll be able to do is to test all the three authorizations problems, the BOLA, the BFLA, and the BOPLA. So you're covered on 1, 3, and 5 from a testing point of view. So something that is important here, we're in the testing phase, we're in the development phase, we're not in the runtime phase. But there is a runtime aspect to all of this as well that we will see after when we talk about the firewall in the subsequent demos. So I'll just stop here for this, and I'll return back the control to Philippe to continue talking about the second problem we want to dive in. We can't hear you, Philippe.
Yes, mute button. Still, after all these years, it still comes back to bite me. All right, thank you for for alerting me now and not like 10 minutes later. Awesome for the demo. So just to recap, the additional properties is true by default, right? So even if you don't have it, it's still considered true. So
Absolutely.
you need to add a false.
That's the key danger of it. It's always true by default, indeed.
Yeah, just to make sure that people don't mistake this demo for like, yeah, you should just set the boolean to false. You should, but it's true by default. All right. Mass assignments can lead to serious problems, by the way. So imagine that one of these properties is not like a fake scan, but you're updating the name of a user, and you can also set a role property, like role is admin. Bam, updated, and I'm now admin just by updating my name. Seriously, stuff like that is not good. All right, let me recap. Authorization, functional level authorization, level 1. Request is coming in. Is the user or is the entity, can also be a client or whatever, are they allowed to perform this particular operation? That's step 1. Step 2 is you do an object level authorization when relevant, which usually it is. Can this happen on this particular object? Like, is the user a part of this family? Yes or no, and so on and so on. And then the third layer is object property level authorization. And that's basically about object properties. Like, yes, you can update the user, this particular user, but can you also write these fields or only the name field maybe? And that's, again, a combination of a whole bunch of properties as Isabelle showed in the demo. And your contracts should be as tight as possible, and your API should enforce those contracts as well. That's essentially the OWASP API security top 10, covered number 1, 3, and 5. All right, good. What's in the middle? 2 and 4. So let's talk about 2 and 4. This is really basic mathematics, by the way. We're talking about security, not math. So fortunately, let's talk about broken authentication combined with unrestricted resource consumption. So when you hear authentication, you think like, oh yeah, passwords and multi-factor authentication. No, I'm not going to talk about that. There's plenty of other resources on that stuff. That's not the goal for today. Today, we're going to talk about a smart scale, which is kind of a gift that keeps on giving, especially security-wise. And in this case, the smart scale had an account takeover vulnerability. As basically, if you had an account there and I didn't, I can take over your account on the smart scale, in this case, by brute forcing the forgot password functionality. So what basically happened in the Smart Scale API is you can do the forget account recovery, like I forgot my password, and they're like, yeah, we send you an email with a 6-digit code, copy pasted into this field. And when you paste something in the field, it sends an API request with the code and you can recover your account. You know how this works, right? Well, in this API story, there was no rate limiting on that endpoint, which means that I, as the attacker, can basically enter your email address, hit the reset, you get a code, you ignore that email because whatever, and I just start guessing, like maybe it was 1, 2, 3, 4, 5, 6, and I can, well, you can do the math on how many guesses I need to make that happen, worst case and medium case and so on and so on. But in essence, that is a very, very simple attack, straightforward to execute with tools like Burp Suite and other software. All right, this is a problem. It's a combination of broken authentication because you can take control of accounts, after which every authorization issue, well, you have control of the account, so you can do whatever you want at that point. So that's a problem. Critical security feature, and it's essentially because of that unrestricted access. That's what's going on. A vulnerability like this can become a dozen times worse, I would say, if you combine it with an account enumeration vulnerability. If you have an endpoint that discloses whether accounts exist or not, I can now start probing your API, like which email addresses are registered. Like, oh, here's a list of 10 million email addresses, and these 1,000 exist. And now I can do an account takeover with the brute force functionality on that, those 1,000 email addresses. And at that point, you are in a world of trouble, at least as the API owner or application owner. And that brings us to an interesting question, which will lead us to a demo in a second. How do you prevent brute force attacks? And it sounds like a very simple problem. Again, like, oh yeah, just only allow 3 requests or 5 requests or something like that. But the real challenge here is when the endpoints are unauthenticated, because the user is not logged in when they're accessing the forget password endpoint. So it's very hard to do rate limiting because you don't have any context around that request. And it means that it's not trivial to implement that. Solutions to this are much more complicated as you think at first glance. And Isabelle is going to talk about rate limiting, resource restrictions in demo time as well. So yeah, I'm going to leave it to her to dig deeper into this.
Absolutely. And while you were talking, I've been efficient and I've deployed a nice firewall in front of our beautiful API. And before I do that, I just want to show you a little picture actually of that setup so you understand how this whole thing is built up. So what I've shown you before is I'm in Visual Studio Code. When I click on this audit, on the scan button, what we really do is, in my case, this goes behind the scenes to our platform, runs this audit, runs the scan, gets the report, returns the information. Okay, this is the interactivity that you get as a developer from the development environment. But a key aspect of our solution is the automation of this, right? As you know, we're talking to a lot of customers that have to protect, not, you know, they have this problem of rate limiting, for example. Of course, they have it on authorization and authentication endpoints, sorry, but they have it onto in many different places. The question is, how do you scale this across all those APIs? So the ability to scale the application, the enforcement of policies as part of an automated deployment is really a critical aspect of what we do at 42Crunch, right? So while Philippe was talking, what I've done is I manually triggered a pipeline in Azure DevOps that basically has been running and deploying a protection in front of our API, which is the one I'm going to exercise right now. As part of that, see, there's something here that says deploy protection, right? So I'm going to show you again some code now. Will be okay. Right, so let's have a look at this API that we just protected. We see we just ran this audit and scan like 5 minutes ago. Again, Philippe was actually talking. We can see we have an active firewall in place that just got configured. It's 6:33. Where am I? So 5 minutes ago. And if we look at the file that is configuring our firewall, so don't be scared, we'll just go, and you know, this is not made for humans normally, so it's optimized. Right, but what we've done as part of the execution of that pipeline is to inject this, right? So why do we like OpenAPI, aka Swagger, so much at 42Crunch? Because it's a declarative way of describing my API. And there's another thing I really love about OpenAPI is it's extensible. You can add, and many vendors do that, add X dash something to the description in OpenAPI. It will still make it completely valid and according to the spec, but it allows you to declare information to it, right? And the things we've been declaring here is indeed that on every single request that comes in, we want to apply some rate limiting. So here, we're not, you know, as I said, an authenticated points, you know, we don't have much of a choice. We could if we had authentication, we had some kind of fingerprinting, we could use that to actually do some rate limiting. But in this case, all we have really are IPs, right? Now, what is really complicated by doing rate limiting by IPs is IPs can very easily be forged, right? They can be forged, or I can go to a cloud somewhere and buy 5,000 IPs for, a limited amount of money. But without going this far, if one of the key thing we need to protect ourselves from is something this little policy here does. So this API I have is behind a proxy, right? So in general, what you're going to do rate limiting by IP, you have to be careful not doing the rate limiting by the proxy IP, because everybody goes through the, all your clients go to the same place. So what you want to do rate limiting by is the real IP from your client. Now, as you do that, you have to be careful about one thing, which is to prevent somebody to just go to burp, or something, and start overriding that header. It could be, in my case here, it's X forwarded 4, it could be X real IP, it don't really, doesn't really matter, where we're going to actually say, okay, X forwarded 4, let me just do a loop and create IPs, right? I can forge IPs and, simulate them as much as I want, which basically makes rate limiting completely useless, right? So instead, what you should do is why we have this option in here, right? Where you're going to put, let's say this is my, whatever, let's say my proxy is at 1043, blah, blah. I'm just inventing something, right? So this is the IP of my ingress controller, right? So what this is going to do, it says, okay, not only I'm going to look at the IP you're sending me, you're telling me your real IP is, but I'm going to make sure, and you have the way to do that, that actually it was changed by that IP you put in here. So nobody can come and forge IPs and override automatically that header, right? So yes, we do, in this case of doing protection of the endpoint, we'll still go with IP, but we'll go a step further by making sure that IP actually cannot be easily forged by such thing. Now, when I'm testing this, what happens on any of the operations? So let's say I'm going to do a login here with some user, 1, 2, 3, 4, boom, then you get hit in here, right? So I'll just and this number we have, like it says 315, right? 3 hits every 15 seconds is being injected automatically as part of the deployment of our firewall, and it's all driven through the definition of the API, of the Open API definition, right? So I don't have to manually create some policies or anything. I'm sure I'm not going to forget it because it's going to be added automatically as part of the deployment of the API, of the automation of the deployment of the API. All right. All right. I'll stop in there for this part, and we'll continue on the next session.
All right, awesome. Thank you very much. I am unmuted, so good. Getting better at this whole online webinar thing. To be 100% clear, Isabelle, you deploy this as a firewall in front of your APIs, right? So you don't have to implement this rate limiting logic in the API at all. That's correct?
That's correct.
Good. See, I know a thing or two about security as well. Awesome. That brings us, no, I'm just the host here. I have no idea what I'm talking about. That brings us to the OWASP API security top 10. One more time. We're going to talk about 2 and 8, broken authentication and security misconfiguration. And one of my favorite ways to do that is by talking about JSON Web Tokens, or JWTs. And JSON Web Tokens are this really, really widespread mechanism. They're really convenient, but they also have some really dangerous pitfalls and things you really should be aware of. And that's what we're going to talk about in the last bit here of this webinar. And before we do that, you here has prepared another question. You kind of had a spoiler before, but the question here is question 2. And that's a question about JSON Web Tokens, just to see where you are with your JWT knowledge. So by default, JSON Web Tokens, they are either base64 encoded, signed, encrypted, or you're not sure at all. We have the results from the previous run of the poll, so we'll just run on that. 64% said base64 encoded. That's correct. Good. So by default, JOTs are base64 encoded. That's indeed the case. 55% said that they're by default signed, which is not true. Usually they are, but they don't have to be. Signing is optional, which is a not so good idea, but we'll talk about that. And then 18% said like, yeah, they're encrypted, which is also not true. They are pretty much unreadable, but they're not encrypted at all. So let me dive into JOTs for a bit, and then we'll wrap it up with Isabelle and her beautiful demos here. On the left, this is a screenshot from a JOT debugger tool, jot.io. Very straightforward. You drop a JOT or you copy paste a JOT in the left thing, and it decodes it into the right thing. And what you see here on the left with the pretty colors, that's a JSON web token. It looks like a very ugly string with two dots in between, separating the header from the payload and the payload from the signature. That's essentially what it means. And each of these things is base64 encoded. And you can kind of recognize that by looking at the EYJ, the start of the string, because EYJ is the base64 encoding for the curly bracket open and then the quote after that, and so on and so on. So whenever you see EYJ, that's base64 encoded JSON. You can literally copy paste that string, put it in a base64 decoder, and you get the stuff on the right. It's just some encoding. It's no encryption. It's most humans can't read that unless you're optimized, as Isabelle likes to say it. But computers can easily decode that. So there's no encryption going on by default. You can encrypt JOTs, but it's a bit more advanced of a use case, and it takes a bit more effort than just running it through a decoder. JOTs are signed in most use cases, signed as in they have either an HMAC or a digital signature, which is a preferred option, by the way, to ensure that the header and the payload cannot be modified. And the whole idea is that you have some service somewhere issuing a JOT with a bunch of claims in there, can be for any use case, but OAuth and OIDC use JOTs heavily. And the signature is there. It's put there by the issuer of the JOT, and the receiver, the consumer of a JOT, can verify that signature, allowing them to verify that nobody went into that payload, the data, and changed the role to admin and stuff like that, because that would result in a failure to check the signature. It would be detected, and it would result in a massive amount of problems. That's in a nutshell how JSON Web Tokens work. All right. Signatures are optional. That's a problem. We'll get to that in a second. All right. JOTs are simple, but somewhat complicated. Somewhat complicated because there's a whole bunch of specs covering all of these aspects. Like the signature is a different spec, and the keys used for signatures are a different spec, and web encryption for JSON Web Tokens is a different spec. And then you have an overarching JOT spec covering some more details. And seriously, it takes you like a week to read through all of these documents and figure out what the hell JOTs really are supposed to be. And then there's like an additional spec, which is probably the most important one, JOT best current practices. As in, this spec has two meaningful sections. There's like a section 1, crap that can go wrong with JOTs, like a whole list of stuff that really goes wrong with JOTs. And then section 2 is more useful. It's like how to fix your JOTs with a whole list of recommendations of what you're supposed to be doing. All right. Seriously, if you need to read one JOT spec, this is the one I recommend, RFC 8725. Now back to those signatures. Signatures are optional. That's one of the problems we have with JOTs, and it's known as the ELG none problem. And the ELG none problem actually comes from a small section in the spec that says like, yeah, should you ever want to represent data as a JOT without really needing to protect the data with a signature, you can set the ELG algorithm to none. Like, this JOT is not signed. And sure, it's in the spec, and everyone's like, yeah, whatever, we're not going to do that. And in real world systems, you're not going to do that. You're going to issue JOTs as the JOT on the left. You're going to create a JOT, add some claims, sign the JOT with a private key, and verify that with a public key. You're going to build your APIs to accept JOTs, and you're going to write a test that says like, hey, if I change something in the JOT and send it anyway, the API will reject it because the signature is invalid. And that's true. That is correct. Your API is very likely to, I have faith in you. I believe that your API does that. However, what happens if the attacker comes around and they create a JOT like the one you see on the right? And the attacker is like, haha, I'm going to take a real JOT from the application. I'm going to open it up. I'm going to change the ELG to none. I'm going to delete the signature. I'm going to change some of the claims, and I'm going to send it to your API. And now I have a question for you. We're not going to do an official poll, but my question to you is, what does your API do? Does it reject the JOT, or does it accept the JOT? Because that's the ELG none problem. And if you're like, yeah, my API rejects it, my next question is, how do you know? Do you think and hope it's like prayers and thoughts, like, yes, it's going to reject it? The only real way you'll know that is by testing your APIs, because it can go wrong really fast. And here's a story of when it went wrong in Apache Pulsar, major open source framework. They had this exact vulnerability. And this story it's really detailed. They had a link to the pull request that fixes the problem in Apache Pulsar. And the pull request looks like this. Bad code on the left in red. We replace the parser set signing key and parse. Apparently that's bad code. And we change it to parser builder set signing key parse claims JWS, and that's good code. And the problem here, in this, it's really, really interesting. I'm a security expert. I would have made the same mistake with this library, because the parse function actually has a logic that says like, hey, if there's no signature, I'm not going to do a signature check, and I'm not going to fail either. I'm just going to accept the token. And the code on the right actually says like, if there's no signature, I know there should be one. I'm going to fail very loudly with an exception. It's Java, so an exception, and I'm going to throw it out. Code on the left is vulnerable. It accepts ELK non-tokens. And the only way you can know that is, first of all, if you know this, but before the story, I did not know about this library. I did not know about that function. I would have made the same mistake. So the only way you can find that and fix that, well, at least when you're a developer not using 42Crunch, the only way to do that is by testing your APIs. And I write that test with my customers. I write that test for my own code, and it would have failed and would be like, what the hell is going on? So JSON Web Token security is hard. Trust me, this is only one of the problems with JOTs. Read the spec. And let's look at some JOT security issues in the real world with Isabelle, and she's going to show you how you can protect your APIs as well.
Before I share my screen, I just want to add one thing which is really useful in that jwt.io address website that you shared. There's a list of libraries, because there's like zillions of libraries in absolutely every single programming language you can actually think of, that there's no standard way of validating a JOT, which is what we're going to talk about now, unless you implement that RFC, which is what we did. But in the same language, you could have 10 different libraries used to create and validate JOTs, and their behavior will be different, not only on the algorithm side and whether they support none or not, but also on which claims they're actually validating. Yep. So make sure you understand what your library does, what are their weaknesses, and maybe you have to switch libraries, in your code on top of the rest, But
yeah, that's a really good point, because everything in JOT is like, hey, you can do this, but it's optional. Apparently even signatures. So yeah, that's a really good point. Make sure to check what your library actually does check, and test it for the things it should check.
Indeed.
All right.
So we just did so this API. So as Philippe was saying, the JOTs, it can be delivered in many cases by IDPs and this solutions that generate tokens. But in my case, this very API, whenever you register or log in a user, will actually create a JSON web token, right? So this is to say AYG. There you go. We'll go and copy this and put it. So I have a different site, but it's all the same. Just to show you. Now, as we said, this is encoded. The green part is the signature. What we're going to do is play with those contents, right? So at the beginning, what I said is one of the key features, I would say, and even the philosophy at 42Crunch is this positive security model, is describing what you're actually expecting in order not to get surprises, not receiving things that you're actually not expecting. Should it be in the request or should it be in the response? For me, if you look at this, this is just a payload. It's a payload which is sent in a different place and sent in the header, and it happens to be encoded. But at the end of the day, it's actually a payload, and a lot of people are actually using JOT to transport data, right? And our API, which is really a bad API and has lots of problems, for example, just goes and takes directly the data from our MongoDB and sticks it there in the user profile directly. So, my game now would be, hey, can I make is-admin true, as we were saying before? That's another way of mass assignment, by the way, not at the payload level, but at the JWT level, right? So anyway, that's our what matters when we are actually dealing with JWTs. It matters the header and the algorithm, as we were saying, with the known, and also the contents. So what I've built is like this simple demo app, which allows me to create tokens on demand, basically, right? So I have the private key to sign them. They are signed. It's supposed to be an RSA algorithm. So this is all good. This is my header. This is my payload. Normally, if I send that request, I get the 200 and I get the profile of the user. Okay, great. Now, behind the scenes on our little firewall, which is deployed in front of our API, there is a policy engage that implements that RFC 8725, we all know by heart now, that has a long list of what you should do to properly validate a job, right? And this is using, again, the same principles of describing what the data should be and the information should be in order to enforce what we're actually expecting. So for example, in my OpenAPI file, because it is, again, extensible, we have described what is the job that we're expecting. So we're expecting a job that has this algorithm, not any other one. And it has to be that type. And that's all we want. And again, additional properties false. We don't expect anything else in that header, which is not in here. And same for the properties. What are we expecting? Well, all this information, right? With certain, so all of it is well defined with patterns, with enumeration, etc. So anything that we are going to send, which is outside of that defined contract, is going to be rejected. That's the idea. Let's start with, the example we were just talking about now, right? And start to say no, okay? Sorry, boom, no, not good, can't do that, right? Which is kind of, one obvious thing, but there is another interesting, and we don't have the time to get in that detail, but there is an interesting attack around JOTs, which is to switch an asymmetric algorithm like RSA for a symmetric one. So HS256 is not none, right? But that's not what I expect. So this is also going to be rejected, right? Because that's not what we want. And same would be, so this is the first thing we validate. So, 3, 4 is what we expect. Okay, so this the header is good now. We can do the same thing for the contents of here. For example, interesting enough, when you are manipulating, one thing which is very important with JOT is the time, the expiration. So how long is that token valid for? And this is, don't create tokens that last one day or a week or a month. That's not the point of doing access tokens. It's really be in minutes. That's what it should be, right? But you also have this thing that says not good before, right? Not valid before. And interestingly, if I'm trying to send that, that's also going to be rejected. It's a very nice claim. It's all good, but it's not defined. So I'm not accepting it, right? So the idea really is that any information that contain in our JOT, so the wrong algorithm, the wrong data, not having, for example, if we don't have issue that, if we don't have any expiration, right? Again, that token is going to be rejected because all of that doesn't match what we're actually expecting. All right, and that's for JWT validation. I just want to keep some time. We have some really good questions that we would like to answer as part of the Q&A, and there is more to learn on our website about JOTs that you can look after if you want to look. Yeah.
All right. Very important note here. You're using a positive security model, as you call it. So when you're basically ensuring that you only accept what you expect. And that's very important because one of the bypasses for ELK none, sometimes there's a code check that says if ELK is none, I don't want it, which is a negative security model. And then somebody figured out if they can capitalize some of the letters, that sometimes the check fails and the token goes through anyway. And that would not happen here. So that's a very good takeaway and a very important point to add as well.
Great point.
All right. Isabelle said, we have some stuff on our website. So yeah, some people write articles about job security. I'm not sure who did that, but seriously, I did one of these detailed articles with a whole bunch of things you should test for and so on and so on a while back. So that's definitely a good reference to look for as well. There's a webinar that digs into a bit more depth on JOTS that you might want to look into as well. And that brings us to the OWASP API Security Top 10. We covered a ton, that's the nice word, a ton of issues here in this 1 hour webinar. I think I'm pretty proud of what we covered here. So that's really good. There's more, of course, there's a couple more issues and there's more beyond that. So a few resources. Here's a webinar about SSRF, server-side request forgery. If you want to dig into that, you can definitely find that on the 42Crunch website as well. And with that, I think it's time to give control back to you. You is going to tell you a bit more about some additional resources, and then we have a few minutes for the Q&A.
Yeah, thanks, guys. That was fantastic. And I don't want to delay getting to the Q&A because everybody's hanging on for that bit, I suspect. So just some additional learning for you. If you're not already aware, 42Crunch is also the name behind APIsecurity.io, which is arguably the industry's #1 API security newsletter. It's produced fortnightly, and if you're not a subscriber already, you can get it there. And then our colleague Colin Dominey has recently published this book. I think it goes live this week, if I'm not mistaken, and you can get it on Amazon. And it's an A to Z of defending APIs. So a lot of the content you've heard today is also covered in depth in that. So that's a must for anybody who's really researching this topic deeply. And then next slide, just some events that are coming up for those of you in North America. Next month, we'll be at the Austin API Summit. If you've never been, it's a fantastic event full of, it's a 3-day event. Day 1 is workshops, and we'll be delivering a workshop on that topic. And we're also delivering keynote presentation during the event as well. And some of my colleagues will be on site to assist you. And last but not least, for those of you in the UK, we'll be hosting a workshop in central London on the 18th, where Colin will be delivering a half-day workshop. It's free to attend. Seats are limited. So if you are interested in any of the above events, you can contact us, marketing@42crunch.com. And we will be sharing, obviously, a recording of the webinar, as I said at the top of the webinar, later with you. So let's just jump quickly to the questions. Question number 1, and I'll read it out, and then Isabelle and Philippe, you can decide which one of you wants to take it first. So, as organizations increasingly rely on microservices architectures, what new considerations arise for API security in distributed systems? First question. And I'm not going to answer it.
I'll say something and Philippe can come on top of it. One of the key things I would say is what's called, east-west control as well. Typically in security, we've been controlling the data that comes in from the client all the way to the back end. In a distributed system, you also have to be careful about the intra-microservice communications as well. The principles that we talked about today, actually, the firewalls I was talking about, it's been this runtime has been created to sit in front of every single individual API, so that indeed, should you receive some traffic from more like maybe an API gateway, which is in front of you and goes to the API, or should you receive some traffic from another microservices calling you, the protection and the policies that we have in place will actually be the same. I'll let Philippe add to that.
Yeah, that's a really good point. We often call those blind attacks because you can attack like an underlying API through the first one and maybe get some data propagated there, and the same issues apply. It's same authorization issues, the same BOPLA definitely plays a role there as well. Another trend I see is the need to propagate relevant information like identity information about the user and authorization information, and that's becoming increasingly difficult. And one of the examples I can give you there to look into that's really interesting is OAuth has this new concept called a transaction token, where you, instead of just getting new tokens or forwarding old tokens, you can kind of get a token about the context of a transaction and then allow every individual underlying API to use that transaction token to verify what's going on and with what the context of a certain request is. And that can help you carry this through your architecture to all the different microservices touching upon a specific request that is incoming at the edge.
Okay.
All right. Awesome.
Great, awesome. Next question is, can BOLA and IDOR be considered the same, or are there small differences?
Also, yeah, maybe we should have said that, like, yes, BOLA is IDOR. So IDOR is insecure direct object references. It's basically the same problem, except that it tries to blame the object references for the issue and not the authorization failure. So the idea is, like, if you can guess the identifier, then you can abuse BOLA vulnerabilities and so on and so on. But it's not the identifier that's the problem, because using random IDs is not going to save you magically from authorization issues. So BOLA is just a renaming to make it more obvious that it's an authorization problem and not an identifier problem. That's correct, right, Isabelle?
I have
Awesome.
nothing to add.
Cool.
Yeah.
Excellent. Okay, I'm just conscious of time. I'm going through a few more quick questions here. What part of a system should enforce the additional properties being set as false?
Well, there's two sides of this, right? So there is the testing side that I've shown, where, you know, from a compliance point of view, you could put rules, for example, in our tooling to say, if you find an issue of that type, then the code cannot go through CI/CD pipeline, right? So that's one way to enforce it from a design point of view, just to make sure this is not done. And then you have the runtime aspect of it, so the shift left aspect of it, and then the shield right aspect of it. And the shield right aspect of it is to ensure indeed that when you are in the runtime and in the firewall, if this is set to false, then indeed none of those attacks are going to go through. And we do that by enforcing what the contract actually says, right? So that's the enforcement part, and the testing is the other part.
Okay, actually, here's a related question. Is there any tool you'd recommend to test the API security in our organization?
Well, we have a favorite one, which is ours, obviously.
Yeah, so I mean, we'll provide a link to that in the
Yeah,
email
absolutely.
with the recording. So I'm not going to promote any other brands right now, if that's okay.
Yeah. So there's two questions from the same person here.
That's
I can
correct.
take the
Yeah.
two if you want, from
Yeah,
Michael.
please.
So from an architecture point of view, indeed, what will happen is you have two ways of deploying what we have.
Read the question, Isabelle. Sorry. Yeah.
Sorry, how does the architecture look by placing the firewall between the API gateway and API? So it's really, there's two ways of deploying the firewall, really. You could either have it in front of the individual APIs, as I was saying, and in general, then you will have an API gateway in front of that, distributing the load, or we could be in front of the API gateway, or both, right? It really depends on, you know, on the in many places it's actually used in both places, because we have to protect those two traffics we were talking about, the east-west traffic in between microservices and the north-south traffic, sorry, from the client all the way to the backend. I guess we have to stop here.
Yeah, I mean that's it. You've covered off the two
Yeah.
questions there.
We'll always, you know, we'll take the remaining questions and put them in the blog that we publish after this, so everybody gets their questions answered. You know,
Great. Well, look,
I know.
thanks everybody for hanging on, and
Yeah.
thanks for all those questions. We'll be sure to get back to all of you directly. Once again, Philippe, thank you very much for joining us on this webinar. We did actually run a series on OWASP 2019 about a year and a half ago with Philippe, so we'll be sure to include a link to that series of webinars as well for those that are interested. And Isabelle, as ever, thanks again for all your demos and contributions.
Our pleasure. Thanks for everyone for attending.
Yeah.
Looking forward to the next one.
Pleasure to be here.
Thanks, Philippe. Have a great evening. Great rest of the day, everyone.
Bye-bye.
Bye.
Bye-bye.